Hi and welcome to this video. Today I'm excited to introduce our newest addition to SLAMD, the Design Assistant. In this quick tutorial I start with some background information and then give you a hands-on demo to show you how this tool can help you in the lab. Our mission has always been to accelerate sustainable material development by providing easy-to-use and cutting-edge AI tools for lab workers and researchers who are pushing the boundaries of green materials. With the Design Assistant, achieving this mission has become even easier. The Design Assistant offers two options. First, it simplifies the creation of new SLAMD projects. If you prefer using SLAMD the traditional way, there's a link in the description to a tutorial. To get started, the Design Assistant guides you through the initial steps and ensures you provide all the required inputs. Additionally, we have something exciting and new: the LLM-powered zero-shot Design Assistant. Here's the thing. Sustainable materials can be extremely complex. The challenge is that innovation requires extensive knowledge, and the pace of knowledge creation is incredibly fast. New resource streams are constantly being investigated, and thousands of papers are published every month, making it hard to keep up. It often takes a scientific career to become a true expert in a material. Meanwhile, practitioners need solutions today. This is where LLMs offer a clever and innovative solution. Trained on a web-scale dataset, LLMs include deep domain expertise that was previously hidden in scientific institutions, but is now accessible to everyone. So, how does this work? LLMs are exceptionally good at extracting and storing concepts from the text they're trained on. These concepts are stored in the inner representation, known as the hidden states. You can easily access concepts and knowledge embedded in the LLMs through prompting. This allows you to tap into the widely reported good practices, but also to combine concepts and latent relationships in the field flexibly. Think of a new material that belongs to a known material class. All relevant knowledge can automatically be transferred to it. For instance, introducing industrial waste streams for geopolymer means that existing knowledge about geopolymers can be applied. Additionally, LLMs can provide information in any format, making it easier to transform complex scientific concepts into actionable formulations that you can implement right away in the lab. So, what makes a good prompt? To access all this knowledge, the Design Assistant guides you through a structured process, ensuring your prompt includes all the necessary elements of your design tasks, such as the constituents, the powders, liquids, processes, and more. It also covers information about your design target, whether it's strength, cost optimization, eco-footprint, or other factors. Additionally, relevant concepts that apply to your material should be included. You might ask, didn't you just say concepts are stored in the LLM? So, we actually wrote a paper on this, benchmarking LLMs in concrete design tasks. It turns out that although these concepts are in the hidden layers of the LLM, performance improves significantly, especially in the beginning, if you add relevant design context or knowledge to your prompt. By showing the LLM what it already knows, you ensure the LLM activates the relevant concepts from its hidden states, giving you the best answers. But don't worry, based on your previous inputs, the Design Assistant creates the relevant knowledge automatically. Additionally, you can add crucial context such as, please consider simple solutions, or we already tried increasing the concentration. What more can we do? This includes boundary conditions and other specific details to refine the response further. Okay, so let's try out the Design Assistant zero-shot design capabilities. And I want to use a case study we've recently published. Although the Design Assistant was not available at the time, I want to showcase how it could have helped us and saved time when we were faced with this design task described in the study. So hopefully this tutorial will give you a practical understanding of how to leverage the tool effectively from the very beginning. So what was this about? In this study, we were aiming to develop a geopolymer binder formulation that exceeded the 100 megapascal strength after 7 days. So we wanted to maximize the compressive strength of this material. We did this in 8 consecutive rounds where we collected data and trained a machine learning model to improve the suggestions in the next round and find a good material after some time. And as you can see, we were successful, especially at the end. We were able to find multiple formulations that exceeded our threshold. So the design assistant would come in here at the very beginning, where we didn't have any training data and made a rather poor choice in the initial data set. So the question is, if we would have collected better data, would we have ended up with these high performance materials much, much quicker? And the design task specifically was based on a powder from glass waste residues. And we wanted to design an activator liquid with a complex composition where some of the compounds were substituted with cheaper byproducts from industry. And the objective in the initial round was to collect training data, which means the data should cover some of the variability within our design space. So let's get started. To get to the Design Assistant, just visit the SLAMD homepage and click on this top menu on Design Assistant, or open the side menu and click on Design Assistant. And you'll be met with our brand new assistant. On the top, you'll find some infos on the usage. And down here, the assistant greets you and tells you all about the functionality. So let's get right to the zero-shot designs using large language models. Just select it. And in the next step, the design assistant explains the process to you. And basically now we're going step by step through the design problem. Start with which material we want to design a binder. Let's add the target property. We could add a custom property or choose one from this list. In this case, we want to maximize the compressive strength. So let's just use this preset and enter the desired strength. In this case, we want to reach a target strength of 100 megapascal. Submit that. Now let's select our powders. In this case, we're going to use geopolymer. And the liquid, going to use an activator liquid. Anything else? No, thank you. We're just using this basic setup. And now we have the opportunity to enter background information on our design problem. And I've prepared a little text here, which summarizes the design problem, basically laying out the background. We have a powder made from glass residuals, glass production residuals and fixing materials, and the composition of the powder. The objective, we want to collect training data, so please increase variability in your suggestions. Your task, find 4 suitable high performance materials on this grid. Okay, we can enter this, we can explain in natural language what we expect from the design assistant. At the bottom also the output format, so we want it in this way. So let's just submit this, and now we come to the part where we can create with the click of a button the general design knowledge for this specific task. So this text now comes from GPT-4o, and it starts with some disclaimer. We can edit this text, right? It starts with some disclaimer and then some concrete design rules for this material and this design target. We can verify them, we can check them, we can add it. We could, for instance, delete this text at the beginning and at the end because it does not really add any specific content. And then just click on Generate Formulations. And we should receive 4 formulations with high variability and good performance for our geopolymer design problem here. Let's see. Okay, we get 1, 2, 3, 4 different formulations. The variability appears to be high. We have high sodium silicate content, which is probably the winning answer. And we have lower ones, and there's a lot of variability in the parameters. So just simple as that, we get a design grid to get started, and just by looking at it, knowing the outcomes of what we tested, it seems like this might actually already be a very good candidate. So I'm really glad we got this result. We can now save it. So now it's saved in the backend, and we can download the session, and then we have it locally uploaded the next time again. So what's new with the Design Assistant? Let's summarize. The Design Assistant now provides easy access to AI-driven materials design through natural language, which makes it much easier to get started. Additionally, no training data is required for zero-shot designs, allowing you to master new design problems right from the get-go and begin with high-performing materials tailored to your requirements. The Design Assistant guides you through a structured prompt generation process, ensuring you include all necessary elements for your design task. Important design knowledge relevant to your task is generated automatically to improve the output. Furthermore, natural language now allows you to incorporate fuzzy concepts such as what's my intention, boundary conditions, and fuzzy design rules into solving your design problem. This means you can seamlessly integrate high-level ideas and constraints into the design process. This makes it much more flexible and comprehensive. Follow this link to try out the Design Assistant today.